In this video, we're going to talk about output streams. Input and output streams are an object-oriented approach for formatted input and output to a file or to the terminal. The two most common streams that we're going to use this semester and that you'll see in other people's code are CIN and COUT. And it's written this way that I'm showing on the slide, CIN and COUT. I've already mentioned in one of the previous videos a little bit about namespaces. These two objects are declared in the standard namespace. So anytime I'm referring to them, I'm going to prefix them with this notation std:::. We'll talk more about the syntax later. But for now, just know that if I want to use the CIN object or the COUT object, I'm going to write it this way with the standard namespace on the front. CIN is used for input, and it's basically the same thing as standard in. And it's equivalent to something like scanf. And COUT was used for output. It's going to allow us to write to standard out or the terminal. And this has similar functionality to printf. And as I said before, these are objects. And as objects, they have public member functions that we can use to achieve some input or output task. Okay, so here's an example of how to use COUT. So in order to use COUT, I need to include the header IO stream. And so I found include IO of my C++ file. And then inside main, I want to print out the value of variable X. So what I do here is I say, okay, I name the object, and then I'm going to use the this special operator, two less than signs back to back with no space in between. It's the shift, it's the left shift operator from C. And that says I'm going to write something into this object. And so the next thing that's going to get written is the string that immediately follows this operator. And it says the value of X. And so that's going to go. And then after this string, we have another left shift operator. And we put the variable X. And so that means next we're going to shift the value for X into the output stream. And it's going to first print the string, and then it's going to print the value of X. Now, the really neat thing here is that the COUT object, it knows what to do. It knows that it should print that string as a standard string, but then it should convert that integer variable X into a decimal form for printing to the output. And if you run this code, it's going to look just like we had a printf statement where we had printed out this string with a format specifier to print the value of X, but you'll note here, we don't need that format specifier or anything like that to get the value of X to print. Really, this shift operator is an operator that's acting on the object, and it may look like a weird special case of the language, but it's not. This is programmed into how the object works, and later we'll see how that's done. But this operator is just a standard C++ operator, and it has associativity and precedence rules. And the interesting thing is it has associativity from left to right, which means when we look at an operator like this, we could, if we wanted, put parentheses around it and say, oh, well, the first thing that happens is the value of X equals, that string is going to get added into the COUT object, or streamed into the COUT object. And then the next thing that's going to happen is this other operator that streams in X. Okay, and the operator figures out that the first operand is a string and the second is an int, and it prints them in the right way. We can do something similar with the CIN object, but it's an input stream. And so what you're going to notice here is that the arrow goes the opposite way. Instead of something going to standard out, something comes from standard in. And so we use the right shift operator to show us that, well, something's coming out of standard in. It's coming from the input and going into that variable. And the arrow into X to indicate we're going to write something into X. And in this case, the CIN object knows that what we want is an integer, and it's going to look for an integer on the input terminal and store that integer if it finds it into X. If it doesn't find a formatted integer, then then X is going to get 0 initialized. At least that's what happens in the newer versions of the C++ compiler. If you go back to a really old version of C++, then it might actually stay uninitialized and report a failure. But in the version of in the modern tools we're going to use this semester, you'll get a 0 initialization if it fails to match an input. Now, CN and Cout are objects, and if you were to go in and look in that header, you could find out the type of object they're an instance of. Right, so CN is an instance of standard iStream, and Cout is an instance of standard OStream. Right, I stands for input, O stands for output, but they're both streams. And the idea of calling them stream is just that you can continually be writing stuff into them or getting stuff out of them without stopping. And so you could go look up these objects, the iStream object and the OStream object. A good website for that is cppreference.com. And I have the link here to the iOStream header. And you could go read up more on these objects and the various public member functions that they support. And that would teach you about how you can achieve various sorts of special formatting rules. Like you might remember with printf, you could say, well, print an integer, but make sure the field that you print is this wide. Or print a string, but make sure it's justified one way or the other, to the left or to the right. Well, you can do the same thing with Cout. There's just a different interface for manipulating it. And so you can go read more about that. I'm not going to talk about it a lot this semester because I honestly don't think printing stuff to the screen is all that interesting. It's just something you have to do sometimes. And so to the extent that we have to do it, we'll figure out how to do it. But I'm not going to teach you all the subtleties of using these two classes. So I encourage you to go learn about them on your own because they do have some pretty nice features. So why bother with these input-output streams anyway? I mean, if you already know printf and scanf, don't you have all the information, knowledge you need for, reading and writing to the terminal? Well, yeah. And printf and scanf are still available in C++, and you can use them if you want to. If I say print something to the screen, it's more than acceptable for you to use printf. Okay, but keep in mind that when C++ programmers build programs, they tend to build them and center them around objects. And CN and Cout are objects. And that gives us certain functionality and capabilities that we don't have with printf and scanf. One of the really neat things that we'll see along is that since CN and Cout are objects, we can actually teach them how to print new objects create. And the same way we said Cout, print a string, we can say Cout, print our new object, and it will just know to do the right thing and to print that object out the way we want it to be printed out. We have to write a little bit of code to make that work, but that's a pretty cool functionality you can get with Cout and CN that you can't really get with printf and scanf. And so those are things we'll take advantage of as we go along. Okay, so in summary, there are two common streams we're going to use. They're an iOStream header, standard CN and standard Cout. CN is kind of like scanf, it reads from standard in, and Cout is like printf, it writes to standard out. And the streams primarily use the shift operators, left shift for output, right shift for input. And these operators know how to read or write the objects based on the type of the object that you're asking them to either print or read from the terminal.